Hello everyone, welcome to my channel C.S.E-Pathshala. We were studying about Python for machine learning and data science, and in this tutorial we will study about Violin plot. So previously we did seen about box plots. Violin plots are also similar to box plots. However, in case of box plots we don't have probability density of the data, while in case of Violin plots we used to represent the probability density of the distribution of the data at different values. So it shows that where actually the data is being more dense and at what places the data is being less. So it's an overall probability where actually the existence of data is being present. These plots also include a marker for the median of the data and also a box that indicates the interquartile range. As we did seen in the box plots also that there has been a mark for the median and also there has been a mark for the quartile values, that is Q1 and Q3. There is an overlaid on this box that is called as kernel density estimation. And like the box plots, Violin plots are also being used to represent the comparison of a variable distribution or a simple distribution across the different categories. That means we have been available with various categories of the data and we will plot all these categories of data in the same figure, and it will be very much helpful to have or to differentiate between all these categories of the data, as we have already seen in case of box plot or the Mixer plot. This can also be done in case of Violin plots, and Violin plots are much more informative than that of a plain box plot. So in fact, while box plots only shows summary statistics such as mean, median and interquartile ranges, however the Violin plots also shows the full distribution of data, that we have already told in the first point that it shows the probability density of the data, which is very much clear that where exactly the large portion of the data has been available, that means how the data has been distributed. So this can be calculated with the help of a probability density. This information is being available in Violin plot. So let's consider a code and then we will understand how to plot a Violin plots. Import numpy as np. That means we are importing a numpy package or a library in a form of an alias, that is np, and it's been used for multi-dimensional arrays. Then we are importing matplotlib.pyplot as plt. That means here our main module or the library is matplotlib. From there we are taking a sub module, that is pyplot, in the form of an alias as plt. Then we are taking np.random.seed. So this we have already seen in the previous tutorial of box plots. This means that we are creating a pseudo random numbers. Okay, and here we have taken the seed as 10. Okay, so pseudo random numbers are those numbers which can be predicted by your system or a machine, and at every execution of your program it will remain the same. So that is the importance of pseudo random numbers. And seed you can take as per of your choice. So as I have told that it will remain the same for every execution, here I have taken 10, you can take any other values also. And the next we are taking certain categories of the data in the form of collection. So here collection 1, that means this is a variable, that is collect n_1, that is equal to np.random.normal. So here we are creating a normal distribution of data in the form of random numbers, and these numbers are having 3 arguments. That means the first one is the mean, second one is the standard deviation, and the third one is the desired values. So here for collection 1, 100 stands for the mean, 10 stands for the standard deviation, and 200 stands for the desired numbers. Similarly, we are taking one more collection, that means one more category, that is your np.random.normal and its mean is 80, its standard deviation is 30, and its number or our desired values are 200, and so on. We have taken collection 3 also and collection 4 also with certainly their mean, standard deviation and desired values. So we are having a category of 4 collections. Now what we have to do, we need to combine these different collections in the form of a list. So here data underscore to underscore plot is a variable which we have assigned to a list, and this list is formed with the help of collection values from 1 to 4. Now we have to create a figure instance. For that we will use a figure method. So here I have declared a variable fig which has been assigned to plt.figure. So this will create a figure instance, and then after creating this figure instance we will create an access instance. So access instance can be created as ax equal to fig.add underscore access. So here's the method add underscore access is used to create an access instance, and it is having a list of certain values. These are 0, 0, 1, 1, which means that left, bottom, width and height. So these values, 0 stands for the left, 0 stands for the bottom, 1 stands for the width and 1 stands for the height. This will add access to the figure which we did created above. And then we will create the box plots. That means it's a violin plot. So bp equal to ax dot violin plot. So violin plot is a method which we will use to create a violin. So here we are giving the argument as data underscore to underscore plot. Obviously the collections which we have taken here in the form of a list has need to be supplied to the violin plot. So on the basis of this collection or on the basis of this category, violin plot has been created which will show all these collections. And the next one is we are saving the result or the output which we will get after the execution in the form of fig2.png. So here we are saving it in the form of a png file. Okay, and this figure will be saved in the drive from which my Python or my Jupyter notebook is running. That means from where the application is running, this image will be saved in that particular location. And then finally we are showing our plot by plt.show. So let's save this code and run this code. As per the output which we have obtained, that means we are having 4 collections. They all are categorized in a same figure, and here if we talk about, these are in a form of a violins. Okay, this is data distribution which we did mention in the point number 1. That means we are having probability density of the data. So this is the distribution of data which we are seeing in a blue color. And here if we talk about, this is the markers. So these markers will represent the median. So here if we talk about the collection number 1, the median is 100 value. For the collection number 2, the median is 80. Collection 3, the median is 90, and for collection 4, the median is 70. And with this figure, it is very much clear that this is in certainly in a form of a box. Okay, and but it is much more better than the box, because here we can see that the distribution of data is much more better than that of a simple box plot. So as we did mention in our points that here the comparison of the variable distribution can be done easily, and it is much more informative also. And apart from median, mode and interquartile ranges, it is showing the full distribution of data. So it's quite clear that the full distribution of data has been available with this blue color. How the data has been distributed throughout this particular range of values, it's been clearly mentioned. So this is much more informative plot. So that's all for this tutorial related to violin plot. We will come up with more informative tutorials on matplotlib. Thanks for watching. Kindly do subscribe to my channel.